This is my sixth video in my module on graphing trig functions. In this video we're going to be exploring reflections about the x-axis. Okay, so basically all of our normal trig functions that we've learned that have just been flipped over the x-axis, or just reflect. So I say so far we've explored graphs of functions such as y equals a sine bx where the values of a and b have been positive. What if now we start to make either of these values negative? And so what we're going to do is we're going to start by exploring, well, what would happen if we made the b value negative here? And that's easy to kind of explore because we've talked about even and odd functions in the past. Recall that an even function is any function that when you plug in a negative, you could just get that negative out of there. It just goes back to normal. So this would be something like cosine. Cosine is an even function. Okay, and then we say f of negative x is an odd function here. Would be f of negative x. You could take the negative and put it out front, essentially. You know, negative f of x, and this would be like sine and tangent. Those are odd functions. Okay, so that being said, we say, well, what if the b value is negative? It says we can use the properties of even and odd functions to rewrite the equations with b values that are positive. So considering these following examples, if we said, well, y equals 3 sine negative 2x, y equals 3 sine of negative 2x. Fact of the matter is, since sine is an odd function, we can actually take that negative and we'll just put it out front. So this would be rewritten as negative 3 sine of positive 2x. And you could see that basically b we could always make positive. We could always do this. It either throws the negative out front or makes it positive, but a is the one we're really going to be concerned with. In this next example where I say y equals cosine of negative 2x, y equals 2, cosine of negative 2x. Since cosine is an even function, this right here we could just basically disregard. We say cosine equals 2x. So the thing I want to point out is this: we really don't ever care if b is negative because we're going to take that negative and either stash it out front if it's odd, or we're going to get rid of it if it's even. Okay, it's the a value that we care about being negative or not. So we'll ask this question now. We say, well, what if the value of a is negative? So in order to explore this question, I say let's consider the graph of y equals negative 2 cosine of x. I say this would just simply be the same as the graph of y equals 2 cosine of x, but with all the y values, they'd be their opposites. Okay, so what I want to do is to kind of just point this out here. I say we'll sketch the graphs of both of these on the same set of axes. So we'll start with y equals 2 cosine of x, since we're really comfortable with cosine graphs, I think, at this point. 2 cosine of x. Identifying a few things first, by the way. We say the a value here, this a value up front is 2. We say the b value, which is this value in here, inside here, so it wasn't a very good arrow. The b value, the coefficient of x, is 1. So we say, well, the amplitude is the absolute value of a, which is 2. We say the period would be the normal period of the graph divided by b. In this case, the normal period of cosine is 2 pi. So 2 pi divided by b is 1. So we say the period of this graph is 2 pi. So to sketch this, here's what we can say. We say go out one period past, 2 pi. We'll split that period in half. And we'll split those halves in half. So we'll quarter the graph up, and we say the amplitude of this graph is 2, so we'll go up 2, and down 2. Let me stretch that out a little further and label these. So we say the normal cosine graph. Recall the normal cosine graph at its inception here starts up at its maximum, a fourth of the way through its cycle, goes down to ground level. Half the way through cycle is down at its minimum. 3/4 of the way through its cycle is back up to ground level. And then all the way through its cycle now it is back up to its maximum. Okay, so it's gone through one full period. Or its cycle here. Okay, so we say here's our normal cosine graph. Now I'm going to switch out colors. We'll go with like a green here. But what if we were to necessarily now graph in green y equals negative 2 cosine of x? What I want you to notice first of all is that the a value is negative, but it has the same size or the same magnitude as this graph over here. Also this, if we were to sketch this, we say a being negative 2, well the amplitude is this absolute value of negative 2. Which is still 2. So we say amplitude is still 2. It's just that by putting this negative 2 out front, we're going to take all of our original cosine values, and instead of just doubling them, we'll negative double them. So for instance, at the beginning of the graph here, we were at a height of positive 2 because we had taken the original height of cosine of 0, which is 1, and doubled it. Now it's at positive 2. If we had taken our original cosine value of 1 and negative doubled it, it wouldn't have started up at 1. It would have started down at negative 1. Okay. If I were to take the original height of 0 here, 0, and doubled that, but with a negative 2, well, negative 2 times 0 is just 0. If I were to take this one, which was at a height of negative 2 here, if I would have now negative doubled the original height, we would have been up here at this now. And then basically what you're seeing is this. All of the y values that we had previously are now their opposites. And so really all we've done was, we have reflected this entire graph over the x-axis. So instead of starting up and going down, down, up, we'll start down at its minimum and go up, up, down, down. And this is very, very true for all trig functions, okay? So we're going to point this out here. We say reflections. It is very true for the graphs of any trig function, such as y equals a sine bx or a cosine bx or even a tangent bx. But we say it'll be reflected about the x-axis if a is negative, which is what we're really saying here. So we say if a is negative, then we have a reflection. Okay, so if this is the case, I don't know, we could sketch one here. We say sketch a couple if we need to, but I think one should be sufficient. And we'll end this video here. But if we were to do necessarily, I'll make something up here. How about the graph of y equals 3 sine, negative 3 sine of 2x. So we'd say, first of all, identify a and b, what we know about them. A is negative 3, b is 2. We're also going to identify the amplitude and the period. These are two things that we need to know before we're allowed to graph this. So we say the amplitude is the absolute value of our a value, is 3. And we say the period of this graph would be the normal period of a sine curve, which is normally 2 pi. We're going to take that 2 pi, and we're going to divide it by b, which in this case is 2. So the period of this graph, it's going to take it just pi to go through one complete cycle. So to sketch this, here's what it would look like. We would go ahead, head over here. We'll go one period past 0. So in this case, we say pi is the period of this graph. And then we'll cut that in half. So we say half of pi is pi halves. And then we'll now split those halves in half. So we've quartered this. We say the amplitude is 3. So we'll go up 3 into the air, down 3 below here. And so now we're going to sketch our sine curve. It's just that since a was negative, we say reflection. And this is the first time we've asked this question, reflection. We say yes or no, and in this case, we say yes. And the reason why is because our a value is negative. So instead of having our normal sine curve that goes up, down, up, we are going to sketch this, but we say starting on the ground, instead of going up and then down and then down and then up, we're going to go down to our minimum first, back up to our ground level, and then up to our maximum, and then back to the ground level here. So we'd say this is our reflected sine curve. So as easy as that, if you see a negative a value, what we're going to do is we're going to do everything we've done the same way. It's just that we'll reflect it over the x-axis when we sketch it. Cheers.